Okay, welcome in. Uh, Greetings, everyone. We'll go ahead and get started. I think that's live. Okay, well, I'll just go with it. It says live, but it's looking a little bit different on the screen for some reason. Okay, so happy Wednesday. I am Professor L, and this is another live stream for math tutoring. And yeah, if you want to see a problem worked out, math that is, you can post it in the chat. In the meantime, I am going to be working on my board, just hanging out, discussing the math. Yeah, see if I catch any students today. So, somehow ended up serendipitously on the topic of logarithms. And so what I've decided to do is I found a function in one of my calculus books, and it's a log function, and it's not a real complicated one. It looks kind of ugly, but I thought it's relevant and related to the topic that I'm working on right now. So I haven't really, I've not worked this problem at all, so I don't know if it's going to be a complete disaster or, maybe I'll have some success. But I do want to be challenged a little bit with this project. So making sure that I'm, putting myself under a little bit of pressure and working on the math. So I have decided I'm going to go ahead and erase everything on the board, and we'll leave the title of logarithms. And yeah, so and I also with this problem will be able to talk about inverses again. So we were yesterday I was working on this logarithmic or exponential function, and we found that the logarithm is the inverse function to the exponential. And so whenever you have a logarithmic function, you're asked to find its inverse, what you're going to end up with is an exponential function. So it makes sense that if you already have a preconceived idea about logarithms and exponential functions and their unique relationship being inverses of each other, then it kind of makes sense intuitively that that will be the case when you're inverting a logarithmic function. But I saw this function, I thought, well, maybe I could do it. So we've got f of x log base 2 of x base 2 of x over, I think it's 1 minus x, or it could be x minus 1. I get those flipped around all the time. Okay, I actually got it right this time. Okay, and the directions say find the inverse and graph the same set of axes and determine the domain and range for each function. Right, and so what we're going to do is, and I didn't have my exponential rules pulled up, but I think the ones that I need for this one is going to be the change of base. And so we'll just see how it goes. So we have y equals, well, and we'll say y equals f of x. Again, this is not me trying to have an authority on the subject of math in any way. I have taught as a professor. I don't have a doctorate, but I do have a master's. I have qualifications, but I'm definitely not an expert by any means. Just hanging out, working on it. I enjoy math, and So we have y equals log 2 of, I'm gonna put some parentheses in the step x over 1 minus x. So it'll help it remain like the syntax is a little bit neater and it'll help the problem solving. I've noticed over the years that the method, making sure that you're writing everything down and keeping everything clean and organized with all of the steps so that it minimizes the mistakes. So, all right. Let me see what I want to do. Oh, it says calculate the inverse. So the very first thing in calculating F inverse is you have to, we're supposed to swap out the X's and Y's. So the process of solving inverse, of course, you can look it up if you want to. And all right, so my stream messed up like 8 minutes ago. And I did not realize that it disconnected. So I reconnected it, and just for because I'm learning, and so I don't really know like the technical things. So I went ahead and tried something new and just tried to reconnect it because I felt like ending the stream and starting another one was too much of a fiasco. I don't want multiple videos and I don't want to have to take down videos. So I mean, I will if I have to, but I just, it's whenever you're learning something new, it's like, okay, I'll cross that bridge when I get there. But yeah, it stopped 8 minutes ago, so I have no idea like where I was in this, how far I got into this live stream. So in 8 minutes, you can cover a lot of territory. And so what I want to do is I'm going to recalculate it. We'll start over. Because I had to. And see how much overlap, and it'll just be interesting for me whenever I work it out. So usually the process of taking your inverse, you're swapping out the domains and you're switching the x's and y's. And so typically you would switch x and y and solve for x. But in this case, what we're going to have to do is we're going to have to change it using this log rule here, which is one of the main ones that I use. I also use change of base quite often. I wanted to go ahead and try it a little bit different and use the change of base. And what change of base it does is it puts it into the same base. So if you have, I think it's log A of B equals log B over log A. And that's kind of what we have going on here. So this would be y equals log x over 1 minus x divided by log of 2. And I don't know if this would actually help, but we could try. So then this is going to be y equals log x over 1 minus x minus log 2, because you have the division equals subtraction. And I wonder, because this is log assumed to be base 10 of x over 1 minus x. So then we can convert the forms. And so then this would be minus log 10 of 2 using that division rule. And then if we wanted to, then now we can probably convert these. So this would be A would be 10. And see, 10 to the Y. Yeah, this might be like a, dark alley or something of math. I don't know what I'm doing right now. We'll see how it works out. I just thought about this after I solved it twice and take advantage of this opportunity. So just using this conversion now here is what I'm trying to do. So got 10 to the Y equals x over 1 minus x minus, this would be 10 to the Y hang on, 10 to the Y we're going to do those two terms separately. So this will be 10 to the Y equals 2, I think. And that did not help me. Okay. I wanted to try it. It was an idea. I don't think it's going to work out though. I'm separating it this way somehow. This can be calculated. This is an actual value because this is just log 2 over log 10. This one, however, we could try to switch out the x's and y's now and see if that helps. All right, let's just not, oh, that's a tough call. What I want to do. I might think about that later. Let's go back to our original problem here, this one. And we're going to convert it to this form. So we're going to say 2 to the Y is going to equal x over 1 minus x. I think that's what it was. So A is 2. X is just that expression and Y is just 1. Okay. And then we're going to, what we're trying to do is we're trying to solve for Y. Okay. So we're going to solve, so we're going to solve it for X. And then we're going to swap out the Y's and X's after we do that. So we'll solve for X. So we've got X times, so this is this entire quantity, 1 minus X. 1 minus X here. And then the sides can cancel, we're left with X. And then this one, you're going to have 2 to the Y minus X times 2 to the Y. And then we have to swap out the places of 2y since we're solving for x. We want everything with an x on one side and everything with the y on the other side. So we'll go ahead and subtract the quantity 2y. And you've got negative x times 2y. And at the same time, we have to subtract x. So we'll subtract it from both sides. And so that becomes minus x equals negative 2 to the y. And then multiplying through by a negative 1. All these negatives will go positive. So this becomes 2y times x plus x. Just rearranging those. And that equals 2 to the y. Then, if I factor a x out of both of these, I'm going to get x times 2 to the y plus 1. And then we're dividing off the quantity 2 to the y plus 1. So we have x equal 2 to the y over 2 to the y plus 1. And that was really challenging. So maybe I need some practice working on some of these. I didn't realize I was going to have so much problems with this. Okay, so we have this becomes f inverse. Because now we're swapping out the x's and y's, the domains, and so it becomes 2 to the x divided by 2 to the x plus 1. And then I think, wait, how did I mess this up? I just left it off for what? 2 to the x. All right. So what I wanted to do was I just wouldn't feel right if I didn't have a sketch. So what I'm going to do is I'm going to erase all of this work, and I am going to just plug in some values. The first thing I want to do is I want to know the x and y intercepts, and understanding, having a visual idea of these graphs. We've got the exponential function that doesn't have a x-intercept. It has a y-intercept, and we have the log function that has an x-intercept but not a y-intercept. So we have those two basic general shapes that we're dealing with, and from that we should be able to go ahead and sketch a table for these functions. And again, if we were just, all you were asked to do is graph it, you could just graph one, swap the domains, and graph the other one. Very easy. But we were just practicing the method, and it's good for you to do the math and be mentally challenged every day. It's very important, so it's fine. So we'll start with our original function and see if what's going on. Let's plug in, since this is my log function, I know that there is a transformation in the graph. I'm not sure what exactly this transformation is doing. I know it's shifting somehow my x values, but it's also got this rational idea. So I'm not sure if the negative suggests it might be going in the positive direction. So I can safely assume there's probably not a y-intercept. There's probably an x-intercept. So if I let y equal 0 and I try to solve this thing, I might be able to find it pretty easy. So let me try. 0 equals log 2 of x over 1 minus x. And 0. So let's see, log x over 1 minus x divided by log 2. Does that help me in any way? Now, let's try and see if we can see what happens when we rearrange what we've got. Oh, that's nice. Wait, 2. So wait, log 2 of x equal y. So we have 2 to the 0 equals x over 1 minus x. So 2 to the 0 is 1. And then times x over 1 minus x. So we're going to multiply 1 minus x times 1 minus x. That's going to give me 1 times 1 is 1, negative x times 1 is negative x. And that those cancel and you get x. Adding x to both sides, 1 equals 2x. And then divide by 2. It's looking like x equals 1/2. So we got 1/2 comma 0 for our log. So we'll say log function, and this will be a to the x, my exponential. So we've got this value 1/2 0. Say we say that one's 1/2. So what we'll do is, since we have this, we'll say 1/2. We'll see when x is 1. We'll just put a couple points in here. 1, let's see, 2, and maybe 3. We'll do. So all we're doing is see how we're using this one now. So since we figured this one out, all we have to do is plug in this number here, because this is wait, that's our y. So y is equal to 0. So when y is 0, it's making me plug in my y. Hang on. All right, so we're going to have to do this a little differently. We're going to plug into our domain. So 0, 1, 2, 3, and see what happens. Okay, it's fine. We'll see what happens that way. So we have 2 to the 1 equals x over 1 minus x. So 1 minus x and times 1 minus x, that is 2 times 1 is 2. 2 times x is negative 2x, and that equals x. So we have negative 2. Let's add 2x to both sides. And that's going to give me 2. And let's see, 3x divided by 3. We get x equals 2/3. So interesting. So how would I figure out this? And it's not me asking the camera. I'm asking, yeah, I'm gonna I can poll the audience. I don't have a whole lot of viewership right now, but it's kind of me using my own brain and trying to recall the information. So it's me, myself, and I. So 2/3. I'm trying to figure out how I would figure out how, because this is what I've done is this becomes y equals log 2. So this is 2 to the y. So what I'm doing is I'm plugging in y here and figuring out x rather than figuring out. Okay. So I am having internet issues, and I do not know if it is my internet or if it's something else. Um, I don't even want to put any imagination into, like, I have no idea what it is. So I'm gonna go ahead. I've got it back up right now, and I just want to say that if it cuts out again, because we're so much into it, like 47 minutes, and I didn't not get to sketch this graph very well. I'm going to do my best to continue working on my board, but I just want to say that if you're watching my videos, and that means a lot to me, because I realize how important, like, viewership is within the YouTube community. I'm starting to realize that, and I'm seeing it, and it is kind of it helps when I know that, people are actually watching my videos. And yeah, if you like my video, it's nice to see that thumbs up. Um, if you don't like the video, then at least tell me why. That way I can know. Um, but yeah, I'm gonna go ahead and say thank you for watching my videos and tuning in. And if you do have a math problem or you need help with your math, don't be shy. And I won't be mean, I promise. I'll be nice. And remember, there are no stupid questions out there. There's no such thing, but there are some pretty dumb answers. Um, and so, yeah, I'll just say, I'll go ahead and say goodbye now, but I really want to try to at least plot some points here on this function and see if they're actually inverses. So if it cuts out again, what I will do is I'll just continue working on this tomorrow. So no big deal. Just chalked up to a win because we did it and we tried our best and we got some experience in the process. So I'm going to go ahead and use the inverse now and see if I can just pick some points naturally and figure out. So I kind of want to know what the inverse is doing around the origin. So I might just plug in and see if I can get maybe its intercept. So since we're dealing with the exponential function, I know it's not going to have a y-intercept.